Okay, so we're on. So I was telling people that you need to know. I made this worksheet as half of being notes, the other half is your homework. All of this should be completed when you turn it in tomorrow. Blah. And it's just solving equations. First one, I'm not going to bother students with this. And where's the new guy? Yeah, your number. So let's see what we got. 5, 10, 15, 20, 21, 22, 23, 24, 25, 26, 27, 28. I'll talk to you at the end of class about what you were in last year and all that other stuff. But you're student number 28. If your number comes up, man, I'm going to ask you questions. But I'll do this first one, right? Whatever. By the way, let's get a group response so the microphone can hear you. Whatever you do to one side is fine as long as you do it to the other. That's really as simple as it can be as long as you're solving equations. And the new guy's probably like, what the heck is this? Am I really in CAT with this simple little equation solver? It's prerequisite chapter. So we always start with this year with little concepts, but we're jamming them all in. Tomorrow we're graphing lines and we're solving systems of equations. So it jumps around all the skills that you're supposed to know coming in. And if I decide to move the ends to the left, then I would want to move the numbers to the right. Please be efficient with your CAT stuff so that you do 2 steps in one. But lo and behold, you look at the right side and you also get 0. All right, and then what does that mean? N equals? Well, 0, not no solution. No one said that, but I get some weird answers like that. And then please understand what it means, because I'm going to do this all throughout. And then when I actually end up calling on you for inequalities, you need to understand what it means that you solved. Meaning, when I take this n equals 0, I could do like a double camera now that I have this here, and I plug it in, what it does is it makes this original equation true. So 9 times 0 is 0. 0 plus -5 is -5. 4 times 0 is 0. Minus 5 is -5. When I plug in 0 for n, I get -5 equals -5, which is true. That's what it means to solve, and that's what we're going to check as we move through. Do you always have time to check your work? Not necessarily, but I'm just making a point of this. Okay, let's get my calculator. Here it is, the glorious. What did I say? 28, right? The almighty student chooser. And let me get the seating chart because I don't know everyone. No, I'm sorry. What's your name again? Jaden. 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 Okay, so if I get you, I'll have to ask that again probably. All right, so sorry. Let's move up. Grab this, but then move it to 28, and then who's the lucky student to start off? Nice! 5, 10, 15. Is that you, Brian? Yeah. Nice, Brian's ready to go. This is fun. All right, get this out of the way. All these things in my way. Okay, hey, whenever you have fractional equations, by the way, whatever I do to one side is fine as long as you? Okay, what is the least common denominator between 2, 5, and 15? Ooh, you're doing greatest common factor. I need least common multiple, meaning what do all these numbers go into evenly? Like, what does 5 and 15 both go into evenly? Isn't that 15? Yeah. But what about 2, 5, and 15? What do all of them go into evenly? 30. All right, so that's what you want to do on that. And then whatever you do to one side, you do to the other. Even though I like fractions, I like to get rid of them. And this is a good idea when you have fractional equations that you have to solve. And then, Brian, how many times does 2 go into 30? So this is 15x. I'm doing an odd, right? I feel like I'm doing 3. Okay, there it is. And then how many times does 5 go into 30? What's 6 times 8? Ooh, you're off by 1, meaning one more 6? Yeah. So 6 times 8 is not 42, add another 6. 48. And then that's what I said about knowing your times tables, making sure you know those things. That's why I maybe said print one. It's not a slap in the face. That's what I see students not knowing. And then how many times 15 go into 30? 2 times 80. Do you know that one quick or no? All right, it's negative 176. Student last hour did it real quick. 80 times 80 is 160. And then 8 times 2 is 16, and then add those two. 160 plus 16 is 176. Then, of course, we know these are like terms, I hope. I don't want to underline it like you think I'm dividing. And then, of course, you probably jump to the calculator. So this is a lot more manageable than dealing with fractional answers. And then I think, double check with me, isn't it 5.3 repeating? Is that correct? Okay, then I'll put some alternative answers. Like that would be 5 1/3, which also would be 3 times 5 is 15, 16 thirds. And good to write that down. Again, knowing your fraction rules. I yell at my students about fractions all the time. Do you know how to deal with fractions and blah, 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 blah. Okay, still probably a little Mickey Mouse here to be asked. I'm just going to do this one. I'm not going to bother a student on this. Well, what's the word that I'm going to use for this? 3, 2, 1. What did I just do? Distribute. So it's negative 10x plus 20. You don't want to insult your, make the, like, what? Are you serious? This is what we're doing? Yeah, I mean, we do need to check these skills. You should have steps written. People that do not do well in CAT don't show their work, and then they don't show a process, then they don't know what they're doing, right? And then that's, if you've been doing this your whole life, I don't know how you got here. That's you gotta really put that effort in for that. And I do want to bore you with this. -9 minus 2 is -11. -11 times -10 is 110. So that's why that's a solution. It made this equation balanced and true. And that's what we need to understand as far as that is concerned. Now we are going to get a student. Nice. Okay, enter. Student number 17. Nice, going in order here. Samantha, you there? Right? Okay, what's the word that we should use yet again? Yeah, and I'll go ahead and do that for you. I'll do the math, and then I'll ask you some pointed questions as we go. So 15x plus 18. Check me if I make a mistake. One quick thing, if this is a minus sign, you better make a plus a negative and distribute the negative, or else you're done. All right, and that's one of the biggest mistakes. Oh boy, negative 15x. They make it plus a negative just for giggles. And then, who was it? Samantha? What do you do next? Well, these cancel out, right? And that's nothing x, and you don't have to write anything about that. But go ahead and add 18 and 25. What do you think you get? All right, so now we got a special scenario. And my pen's not writing. Oh, come on, kick in. It looks like it's supposed to be writing, but now yay! All right, I love it. It's really starting to shut down. That just shut down on its own. We got something going on with my computer here. Hopefully it survives these notes. And then I'd put a, what? Write this down. So here's what happened to you. You lost your variables, but what's left over is true. Huh. Do you know, Samantha, what that means? Yes or no? Otherwise, I'm going to throw it out to the class. Throw it out to the class. What does that mean? X. I was making sure it was X equals. Good. We got a hand right off the bat. Okay, so all, what do we say? All real numbers. Don't say infinite amount of solutions. That actually means something different. But remember in the last question, I checked my x equals -9. Well, let's analyze why is it all real solutions. And I'll tape myself as I walk to the thing here. Just look at before this. No matter what I plug in for x, if I plugged in 1,000, when I plugged it here and here, these two would cancel each other no matter what. It'd be like 15,000 and -15,000. And then I'd still be left with 43 equals 43, which is what? It starts with a T. It starts with a T and ends with a root. I don't have time for this. True! So any number that I plug in here, or even in the previous step, would make this equation true because the variables cancel out. So that is why that is an all real solution scenario. All right, this is why I get students to answer questions individually, because usually when I ask group questions, they don't answer me. Right, Grant? All right. Grant, what's the word? And then I'll do it. Distribute. We'll get this taken care of. So -8x Just be ready. Be on task here. Uh-oh. Okay, yep, good. And then this is negative 40. And then I'll do this for you. 16 minus 2 is? All right. And then what would you do next? And then what would you do to both sides? And then what happens? We'll stop you right there. What happens when you add 8x to both sides? These completely destroy each other again. But then, Grant, look at what you have. You have 14 equals negative 40. Or if you decided to subtract the 14 to get it on the other side, you'd still have 0 equals negative 54, I think. True or false? All right, so here's this scenario. You lose your variables, but what's left over, my pen is being real bad right now, so bear with me. And what's left over is false. Do you remember now, Grant, what that means for this scenario?
No, I don't.
Okay, can anyone help him? Nice. This is no solution, meaning there is no number that I could plug in for x that would make this equation balanced or true. And just analyze it on this step here right before we cancel them. I throw like 100 here. These two would nullify each other, and I always end up with a false statement no matter what. So therefore, there is no number that could satisfy this equation. So I did want to get those two in there. I did do that on purpose, these special cases, because sure, we know how to do our undo operations, I hope. Whatever we do to one side, you do to the other. But then what do we do in these scenarios? You know, when that happens, that's the analysis that we need to have. Not that you haven't seen that before, but it is very forgettable, right? And students usually do forget that, and that doesn't work out too well. Okay, I'm actually going to go up to the top of the page and have you add something, but who's my friend? This is how I pick my friends at home, by the way, with a calculator. You're my friend now, Ashley. Sorry. All right, Ashley. My phone's going off right now. My phone, my friends. Speaking of friends, yeah, it's them. Oh no, it's actually my daughter. Ooh, I should watch that. There might be a problem at home. Probably has to do with golf. Hey, Ashley. Absolute value of x equals 4. Again, remember what equation solving can be. Sometimes you can just think about what does work. And what does work? The absolute value of what number equals 4? And what else? You're right. So there's two answers. I'm not writing this down, but the true definition of absolute value is this is asking what numbers are 4 spaces away from 0. 4 is 4 spaces to the right of 0. Negative 4 is 4 spaces to the left of 0. That's why these are the two answers. For all intents and purposes, you should know that the absolute value of a number always is the positive. So absolute value of negative 3 is 3. Absolute value of 7 is 7. All right, because you're actually answering that distance. But that's what we should know here. So here's what this one is, and I'll set it up for you. We don't have this in step 1, but here are our quick steps for solving absolute value equations. First thing is isolate the absolute value. What I mean by that is there anything outside of the absolute value that needs to be moved around? Do you have that in this one, Ashley? Yes or no? No. Now we move on to step 2. Set up your two cases, the plus minus cases. And then really step 3 is solve and maybe check. Solve each and then check. And we are going to check just to see, did we just do something valid or not? And if you have time to check on a test, check. If you don't, then move on and then check at the end. So it's already isolated. Here are the two cases. You drop the absolute value because this is the definition of absolute value. I have something that is 2 spaces away from 0. So that thing should equal 2 or it should equal negative 2. This is ultimately what is occurring. So there you go. There's your two cases. You don't change the plus to a minus. I see people do crazy things like that, making up the math. It's whatever's on the inside of the absolute value equals positive and negative case. And then I'll take it from here, Ashley. We'll just actually probably ask you to check your answer. Subtract 6. I'm not going to show the minus 6 both sides. You juggle yourself if you want to show your undue operations. And then be careful in dividing by 8. This is not negative 2, it's negative 1/2. There's a difference between a half and 2. So make sure you do that correctly. So show the dividing by 8 so that you see it's 4/8, which is 1/2 with a negative on it. Then I'll slide this over and subtract 6. That makes this negative 8. And then divide by 8, that gets me negative 1. Okay, Ashley, I didn't ask you too much, so now I'll ask you this. Let's tackle that half first. What's negative half of 8? What's negative 4 plus 6? What's the absolute value of 2? Still 2. People last hour tried to say negative 2. No, it's still 2. Does 2 equal 2? True. All right, negative 1 times 8 plus 6. What kind of 2? Oh, do it again. Negative 8 plus 6. But then what happens when you absolute value negative 2? Turns into 2, and then 2 equals 2 is true. That's why these two answers work. This is what we need to do. Got it? Alrighty then. Let's see if we get the next person to do this right. This is fun. Lucky number 13. 8. Nice. Going down the row. Kennedy. You ready? Fumble. What do you do first, do you think? Oh, never. Because if you distribute that negative, the absolute value is going to turn it into a positive, and it's not. Not subtract. What's the operation? Divide it. So here's step 1. I'm not writing it again. Isolate the absolute value before you do 2 steps. So the opposite of multiplication is division. So we went through a couple things. We distributed. Can't do that. We actually, and this is a common error. You said add, right? No, it's the opposite of multiplication. So make sure you do read that operation correctly. So common errors. I'm glad that happened. Making sure we do that. Now our 2 cases. So Kennedy, tell me what I'd write first, following along what we did last time. Here, I'll start you off. You free it from there. What does this equal to first? 10. And then what is 4n minus 2 equal to again? So what's 10 spaces away from 0? 10 and also what? Negative 10. Okay, I think that's what you said, right? Okay, so that's what you do. All right, that's the definition. There's different ways of that's what's happening. Let's just be practical. Add 2, divide by 4, add 2, divide by 4, and then we're going to check Kennedy. I almost said Ashley, but that was the previous one. Kennedy, just get ready for this. Are you ready for this? Boom, 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 boom. What's 3 times 4? 12 minus 2. What's the absolute value of 10? Just 10. What's 10 times negative 5? Just say that number. What's 10 times negative 5? Negative 50. Now let's take the negative 2. What's negative 2 times 4? What's negative 8 minus 2? Be careful. What's the absolute value of negative 10, though? What's 10 times negative 5? True. All right, so that's why these work, and that's why those are the solutions. Boom shakalaka. All right, ooh. All right, here we go. And then I like this one. Went crazy with you here. It's student number 26. That is David, right? David, what do you think you'll do first on this one? Remember step 1, isolate the absolute value. Oh, wait, no, it's this David over here. Oh, I like that, though. He can go right now. Hey, cover your nose. It's getting close there. All right, go ahead. I think that's what he said. What would you get rid of first? Not dividing. Oh, would you combine the negative? No, because this is -9 times, and then this is -3 on the outside. So you can't divide by -9 first, because then I'd have to divide this by -9, and I'd have fractions. So I'm kind of giving you a hint. You definitely got to get rid of add. Think of it this way. Look at this one. Don't write this down. -9x minus 3 equals -21. Wouldn't you add 3 first, right? Then divide by -9. So that's what that middle stuff. It's working like the variable. So you want to add 3 first, then what? Then divide. When I add 3, this becomes -18. Then divide. What does that become when I divide by -9? And I'll show it, I guess. Divide by 9, negative. What does this become on the right? What's -18 divided by -9? 2. And then what are my two cases? And I'll do the work for you here. So what's -2x minus 10 equal to first step? That's -2x minus 10 equals 2. So what does this equal here? You want to put -2 first? Okay, then what's the other one equal to? What's -2x minus 10 equal to over here? Okay, fine. You want to, there's my pen going a little bit crazy. That crazy equal sign. Let me erase that because now that almost looks like there's a negative floating there. So he wrote negative first, then positive second. Ain't no thing, chicken wings. Okay, so again, no distribution. No, you don't get rid of division first. You get rid of subtraction first, then division. Or multiplication, get rid of that by dividing. And then go ahead and do your two cases. Add 10. Going to kind of run out of room on this one. That's 8. Adding 10 to -2. And then x equals -4. Kind of squeezing my work here. Add 10. I guess I could have flipped this up to the other side. So add 10 to this and I get 12, right? And then divide by 2, I get x equals -6. And then because of time, we're not going to worry about checking. So x equals -4 and -6. All right? Everyone okay so far? Absolute values. You got to follow this process. This is why I like how I did these notes. It expands. It keeps going. Gets a little bit more complicated. So this could be considered like the new stuff. This is what you got to lock in today. And I know what's going on here. So now what I did is the next section was to solve inequalities. And I went back to what I would call linear inequalities. And I know you probably already recognize something in this one, but just ignore it for a second. I'm going to do my fraction stuff, Sarah. I'm going to do my fraction thing. Like, what's the common denominator between 8 and 3? Because whatever I do to one side, you do the other, and I'm going to multiply both sides by this least common denominator so that they all get destroyed. The fractions go away. It's just these two multiplied together, which is what? What's 3 times 8? 28, 16, then add another 8. 24. Okay, now we're going to multiply both sides by 24. And I know those already know this is going to happen, but let's see it. I just want to have an idea about how to deal with fractions. Actually, this was an accident. I really wanted this one to work out, but it doesn't. Hint. Okay, how many times does 8 go into 24 then? How many? 3? And then what's 3 times 13? That was a tough one, but what's 3 times 10? Don't press that calculator. 30, and then what's 3 times 3? What's 30 plus 9? 39. So 3 times 13 is 39. All right, so this becomes 39n. That is the point of multiplying by the LCD. 8 goes into 24 3 times. That means it cancels with a 3 left over, 3 times 13. Same thing happens here. Minus. Oh, and I saw that up there already. And then 24. How many? 3 goes into 24 how many times? I'm going to ask you a times table question again, Sarah. So 3 times what equals 24? The number's here. How many times does 3 go into 24? 8. Okay, here we go. What's 8 times 7? You know your times tables? Give you a hint. Starts with a 5. 56. Okay, so know your times tables. It'll go a long way in this class. But oh no! What happens to the ends, everybody? Say it out loud. They cancel. But now listen. Back to you, Sarah. One more question. Is this true or is this false? What's left over? So I lost my variables. What's left over is true. What does that mean n is equal to? It's the same as equations. All reals. It doesn't matter what I plug in, the inequality will be true. So again, this is why I made this a catch. Sure, now we have an inequality and we want to, write the answer and blah, blah, but then with the special cases again. All right, so that's what this was an accident. I didn't really want to have that happen, but it did. By the way, doing that on a number line, it just means everything is colored in. And then raise your hand if you know how to write this in interval notation, because look, I got to use interval notation. Raise your hand if you remember how to do all real numbers in interval notation. Every hour someone was able to do it. Come on, anyone? Yes, thank you. What do you got? Nice. And what is always on infinities? Bracket or parenthesis, you got it. So there is the interval notation for all real numbers. Please recall that, okay? No solution, you just say no solution. It's like a null set, 0 with the slash through it. Could be the case there. Okay, yeah, we're going to bother you on this one, but we also have to do interval notation on this too. So student number 15, nice. Is that Brooke in the back? Oh, this thing keeps getting in my way for the... Okay, what's the word? Just tell me the word now. Do it. Distribute. So I got you. You get 6 plus 66. Oh, okay, it's just minus 10. But remember, if that was a minus 10 times parentheses, you'd have to distribute the negative. So please don't make those mistakes. 55p minus 15. I'll kind of force the issue here with you, Brooke. 6 minus 10 on the same side. What's 6 minus 10? All right, and then what would you do after I get this cleaned up? So what do you want to do to both sides? Where do you want the p's, left or right? So what are you going to do to both sides for the p's? And I would probably write this one down just to organize my thoughts. So I got rid of this over here, keep the balance. Who should I move now? -4 or -15? It is -4, and we'll do that by adding. Lo and behold, it doesn't always have to happen, but this one did end up being nice. By the way, tell me what I do next. What's the undo operation? And you're not dividing by a negative, right? I'm just asking a question. But someone raise their hand. Tell me if you know what happens in an inequality when you divide by a negative. Nice! Break into the class. The symbol flips. And I'd like to describe that with numbers, but I don't care. At this point, you should know it as a rule. If you had to divide by a negative here, then this would flip to a less than. And we need to remember that. And that is something that is, expected, I guess, of you. I used to explain it, but then the more things I explain, students get jumbled with too much information. Okay, I'll go to another student. You got it actually at least light on what you got to do, but we're still going to see if you know what you're doing. Grant's in the back. When I graph this, so when I graph that, what do I put on -1? Open or close circle? Ooh. Ooh. So what does that mean? Closed. When you have an equal to, it means included, which means colored in. And then which way do you shade? Where are the numbers greater than -1, right or left? So I shade to the right. But now, Grant, you got to put this in interval notation. So just remember, Grant and everybody else, it's got to be in order of the number line. So I will be starting with -1. To help you out, Grant, what number is way over here? Forever. So that's what we're going to do. But what do I put on -1, a parenthesis or a bracket? There we go. So it's -1 bracket, comma, to infinity. It's got to be in the order of the number line, reading left to right, how we answer that question. Now, I will stop and show the calendar real quick and show you that when I use this worksheet generator, I love it because it also online, there's the worksheets, but then the worksheet is blank on pages 1 and 2. But then look at page 3 and 4. What do you see? What are those? The answers. Now, they give algebra 2 answers, so they don't have interval notation. You're going to be on your own getting interval notation correctly. But at least you'll be able to read the inequalities and understand that you're on the right track, I hope. Okay, but here we go. Look at that work I had to do. Any bum? That's what I said, bum. That is just showing answers. You're just copying the key and you're not fooling me. And you're going to get no credit. And I'm just done with it. That's there for the people that do the right thing, where they go through the process and then have that happen. Okay, oh boy. So how is this different? Student number. I guess we'll have you just do one thing. Student number 20. 5, 10, 15. Is that you, David, in the back? I think it is, Dave. 5, 10, 15. Yeah, Dave. Dave, I'm going to actually have you answer this question. Let's go back up to the top of page 1. Remember I forgot, Ashley, did you do this one? You the 4, -4 thing? Dave, I got a tougher couple questions for you. What if it was the absolute value of x is less than 4? Stop it. Don't answer yet. Give me 5 numbers that make this inequality true. Now answer that. Go ahead. 1, good. 2, 3, -1, -2. You got your 5. How about this? What about 3.9? Would that be good? Yeah, because you ignore decimals, but decimals would be true, right? What about -3.9? True, right? The absolute value of -3.9 is still 3.9, less than 4. This is really what's true. X is all numbers between 4 and -4. That includes all decimals as well. And that's how you'd write it as an Algebra 2. Algebra 2 exists in 99% of all the other schools in the state of Illinois. We just have Math 1, Math 2, Math 3. But you've seen inequalities before in this grouping little sense. And then, David, I'm going to bother you one more time. What if I said the absolute value of x is greater than or equal to 4? Give me 5 answers that work. A couple of them maybe being negative. 4 works now. Correct. Oh, 3. Careful. Absolute value of 3 is 3. You went the wrong way. 5. What else? -4. Oh, sorry, I put the wrong finger up. -5. And then 5, 6, -6. These go forever this direction. So what would be the true answer for this? All numbers that are less than or equal to -4. I pen skipped. Or all numbers that are greater than or equal to 4. All right? And then that's what we'd end up having there. All right? So it's one or the other. And those would be the ones that you listed. Isn't that correct? Because you could have went forever. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And then we could have done decimals. 4.1, 4.2. Oh, gosh, it goes forever and ever and ever and ever. So I want you to understand that this is not just going to be 2 answers. You actually have an infinite amount of answers. Now, Dave, when I get to the next student, remember your first one was a less than or equal to or less than, and you remember it ended up being like an in-between. That's what's going to happen with this, if you can remember that. So let's analyze it, though, how we're going to do this in steps. Enter. Nice, 27. That's Kaylee. Kaylee, you're still going to do the same steps as if it were an equation. You're going to isolate the absolute value. Is it isolated, Kaylee? Meaning, is there any outside operations? No, there isn't. So you already have step 1 done. Step 2 is exactly wrong. You are going to set up two cases. As an equation, and it is the plus minus cases. You're going to ignore that you have an inequality for the moment. So you're going to pretend that says equal, and then solve it like it's an equal. So tell me, what does 1 plus 2m equal? What are you going to put equal first? 5, true. And then what's the other case? So you kind of keep it the same, but then at the end, you analyze, wait a minute, I have an inequality. This thing is just going crazy. You guys see that? It's just, we're going to make it. I think we're going to make it. We only have a couple more to go. We only have one more to go. Right? And then my face is in the way, so we're going to move this. And then, Kaylee, I won't bother you. Subtract 1, that's 2m equals 4. And m equals 2. But I'll show you what we do differently, and I'll show you step 3 on inequalities. Subtract 1, that's negative 6. And then m is equal to negative 3. Okay, Kaylee, first things first. Let's go back to the very beginning when we had inequalities. Open dots or closed dots on those two numbers. What do you think? Open or closed? Closed because it's equal to. That means 2 is a solution, and that means negative 3 is a solution. Just like when Dave said when he had the equal sign, he said 4 does work, and negative 4 does work on that m is greater than absolute value of m, or x, or whatever, greater than or equal to 4. Right? So those are open. Now, here's what you actually do. And this is going to happen when we go into, I think chapter 2 is when we do inequalities again, but with quadratics and cubics and all this other stuff. You do a number line test. You do a number line true-false test to figure out what works. And I'm going to emulate that right now. Although, David, didn't I just say it should be in between, right? And you can kind of remember that and do that. So the first number I'm going to check is a number in between, which is 0. And go back to Kaylee. When I plug in 0, first of all, what's 2 times 0? What's 1 plus 0? 1 plus 0 again? 1. What's the absolute value of 1? Is 1 less than 5, true or false? So this is true, which means any number I would have picked here would have been true. This is why the very first example of the day, I checked my answer, because this is what we're doing. We're getting all the numbers that actually make the inequality or equation true. This is an inequality, so there's more than just 2 answers. There's actually an infinite amount of answers that work. If I would have tried negative 2, negative 1, or 1, they also would have worked. And then, you know what happens? This is going to be false, but I'll prove it and not bother Kaylee with it. Negative 4 times 2 is negative 8. Negative 8 plus 1 is negative 7. The absolute value of negative 7 is 7, which is not less than 5. False, not shady. 3. 3 times 2 is 6. Plus 1 is 7. 7 is not less than 5. This is a big time false as well. So, it is everything in between. Kaylee, I will bother you for the interval notation, though.
I have a question before that.
Go ahead.
So for 19, instead if you divide by a negative, use a sign split.
But I divide it by a positive.
So even if there's like a negative.
Even if that's negative, it doesn't matter. This doesn't flip. Okay? Yeah. So definitely. But if this was negative 11p, if I divide it by a negative 11, that would flip and turn into a less than. So now back to interval notation. Brackets or parentheses? And then wouldn't it just be bracket? I like putting it up here. Bracket negative 3 to 2. And that's the interval notation final answer. It's always good to do interval notation after you see the graph. You know, then I see the graph and say, okay, it's like copying the number line. Really is what interval notation is. Last but not least, you're going to love this one, whoever student this is. But again, this comes into not being a robot. Oh no, is she going early on me again? I guess I lost some time with our. Who was that? Who's 26? Is that you? That's you again, David. Nice. What do you do first, David? Remember, isolate the absolute value, huh? Minus 6. Then, David, I want you to think. Don't be a robot. What is this always going to be no matter what I plug in? What kind of number? Starts with a P. P-O, huh? Or the smallest it could be is this number, 0. No matter what I plug in for A, this could only be positive or 0. David, what's wrong with this picture? What are positive numbers? Never. Never less than a negative. So what do you think A is? Not, anyone? Not possible to solve. Do you get this? So you're going to be a robot and do like 2 cases on this. This is a bogus scenario. The absolute value of something is always going to be a positive, or 0 is the lowest it possibly could become. This could never be negative. So this is, before doing any math, no solution whatsoever. So again, people get stuck with, okay, this is what I have to do, step 1, step 2, step 3, step 4, and they lose focus on what they're actually solving in the first place. You know, the definition of it, what's going on behind the scenes. So that one I did on purpose as well when I picked that one, because then, you know, you could have solutions like this, or scenarios like that is the best way to say it. All right, we had some tech difficulties, but we got through.